carcinogens. So the government has to decide how much of these kinds of things are going to be acceptable in our drinking water, and if there's more, then they have to treat it. So you can understand that if you were a government regulator, there is no way that you're going to tell the population that almost everybody has 10 times more lead in their blood, for instance, than is acceptable. Or that everybody's drinking water has twice as much mercury in it as is acceptable. So there's quite a bit of pragmatism that plays into setting of targets and regulations within government. Now we're going to talk, just for a minute, have a quick little biology lesson, just so that you understand the kinds of effects that chemicals may have on your body. So, of course, everybody's heard of DNA, and that's essentially all the recipes for all the proteins in your body. It's like a library. And so when your body's going to make a protein, it goes to the DNA, and then it manufactures that protein, and then those proteins are building blocks, and they also are enzymes that carry out other reactions in your body. So that's one half of the genetic makeup picture. And some chemicals actually damage the DNA itself. We now realize that there's a second component in this. It's called an epigenetic effect, and some chemicals affect the methylation of DNA. And what this is like, they're like bookmarks in the recipe book. So they're bookmarks for good recipes, or maybe bookmarks for bad recipes that you'll never repeat. And exposure to chemicals can actually change the predominance of the types of proteins that you make in your body, which can have effects on your health as well. And all of these genetic effects can be passed from one generation to another. So if the mother or the father is exposed to certain chemicals, then that can actually affect their child through either genetic or epigenetic effects. Another important system is the nervous system. Of course, the brain is an important part of that. The brain has a lot of fat in it, and some chemicals that we're concerned about are very fat soluble. They like to collect in fat, and these can affect the function of the brain. The nervous system operates by sending essentially electrical signals along nerves, and so that can be impaired. But the other part of the nervous system, we have the nerve impulse that goes along the nerve, but then there's chemical reactions that occur when the signal goes from one nerve to the next nerve. And so there's several ways that the nervous system can be messed up. You can have fat-loving chemicals that impair the function of the brain, or you can have these chemical reactions impaired. Now, the nervous system, of course, is what allows you to move your hands. There's certain parts of your nervous system that are conscious, and then your nervous system also looks after how quickly your heart beats, and how quickly you breathe, and how all of your other bodily functions that you can't actually usually control yourself. Now, another messaging system in your body is the endocrine system. And the endocrine system is linked with the nervous system. But the endocrine system is a chemical messaging system. So it sends chemicals throughout your body. We call it hormones. And some chemicals can interfere with the operation of these hormones because they actually look chemically a lot like the hormones, and so they will bind in places where normally you would have that hormone binding, and then it's an inappropriate response from the body because it's an inappropriate chemical that's binding in the wrong place. Now, the endocrine system affects your metabolism. whether you have a lot of energy, if you feel cold all the time. It's also part of the reproductive system. And then finally we have the immune system. That's what allows you to fight infections. And interestingly, the immune system in some cases can be upregulated, or at least aspects of it can be upregulated. In some cases it can be downregulated depending on what chemicals you're being exposed to. And if the immune system is suppressed, then it's not active and you're more likely to get infections that are more serious and more frequent. If the immune system is stimulated, then perhaps you don't get so many infections, but you're at risk of autoimmune disease such as arthritis or diabetes. And interestingly, either suppression or stimulation can lead to certain kinds of cancers, because the immune system is responsible for surveillance throughout your body, watching out for the very first cancer cells that develop. And so if you don't have a strong immune system, then cancer cells will get missed and they'll develop into a tumor. But if your immune system is stimulated, then you can actually get cancers of the immune system, because you have these cells dividing very quickly and there's more likely to be mistakes made that are not caught. At this point we have to mention that children are most vulnerable to chemicals in our environment that we're not used to being exposed to. They absorb more toxins per unit body mass. They're very immature, so their organs aren't yet able to handle chemicals the same way as adult organs can. And they're also very, they're developing with key events that have to take place in exactly the right way, in exactly the right time, in order to have the brain develop and so on. And if these get messed up at just the wrong time, then you can have birth defects, or you can actually change the architecture of the brain if there's exposures of the mother at the wrong time during pregnancy. And these exposures can be ones that don't even lead to overt symptoms in the mother, for instance, with some insecticides. There's been animal research showing that permanent changes in the child's brain, or in the pup's brain, can occur with no symptoms on the part of the mother. And these effects, as we said, can transcend generations through epigenetic effects. Now, we'd like to hope that our government is looking out for all of these possibilities. And unfortunately, it's not really true. They're playing catch-up, actually. And so under the Canadian Environmental Protection Agency, Canadian Environmental Protection Act, we have regulations and procedures in place for new chemicals, but they're playing catch-up on the old ones. And so there's been big screening exercises and just setting of priorities, and it's led to a few chemicals being banned and some being restricted, but more or less it's carrying on business as usual. Now the Canadian Health Measures Survey and the Maternal Infant Health Survey are proceeding, but it's going to be quite a few years before we know what chemicals are in our children and in our bodies and what health effects they're related to. So right now, we are operating in the dark to a large extent. When a new chemical is going to come on the market, such as a pesticide or a drug, then there is quite a bit of scrutiny. For other chemicals, there's much less scrutiny. But when the government sets out to decide whether to allow something to be sold or not, there are basically 3 steps that we'll walk through. And whether they're going to decide on sale, or whether they're going to ascertain how much should be allowed in drinking water, or what levels of contaminants would be acceptable in soil, or whatever, it's the same basic process they go through with a few tweaks around the edges. So basically they have to start off by finding out how much an animal can tolerate. And this is usually information that's supplied by the industry. It's based on laboratory experiments